All right, let's look at the homework 3.2, 3.3, problem number 14. All right, so we have the derivative of f of x is given, and we want to answer the following questions. All right, so part A, find the intervals on which f prime is increasing. So we just need to take another derivative. So it would be f double prime of x is equal to, all right, derivative of x squared is 2x, and derivative of 5x is 5, and derivative of negative 36 is 0 since it's a constant. So we set that equal to 0, and we can see that x is equal to negative 5 over 2, right? Then we can just do the number line here. All right, then we have, I'm going to put a tick marks for negative 5 over 2. All right, then we're going to look at the f double prime. So we're going to try any number less than negative 5 over 2. So I'll try negative 3. Right? If you plug in negative 3, negative 6 plus 5 is a negative number. Right? And we can try anything bigger than negative 5 over 2. So I'll try 0. Right? 0 plus 5 is positive. Right? So we know that f prime is decreasing on this interval, and after that it's going to be increasing, right? So the increasing interval is going to be from negative 5 over 2 to positive infinity, and decreasing interval would be a negative infinity to negative 5 over 2, right? So let's type it in. So we have, let's see, negative 5 over 2 to positive infinity. All right, and here is a negative infinity to negative 5 over 2. All right, so let's check the answer. All right, we got part A correctly. All right, how about part B? Find the interval on which the original graph is concave upward and concave downward. Right? Remember the definition of concave upward is the derivative is increasing. So we have the same answer as part A. So it's going to be negative 5 over 2 to positive infinity. Right? And if the derivative is decreasing, it's concave down. So we have negative infinity to negative 5 over 2. Right? Alright, let's check the answer. Alright, I came back and we got part B correctly as well. Alright, so let's look at part C. Find x values of the relative extrema of f. Alright, so we want to find the relative extrema, so I'm gonna go here. Alright, so first thing we have to do is we have to find the critical number. So we're gonna set f prime. So let's see, f prime of x is equal to, alright, so you have x squared plus 5x minus 36. So I'm going to factor this guy out. Alright, so you have x and x. So it's going to be probably plus 9 and minus 4. Right? So if you set that equal to 0, we know that x is equal to negative 9 and positive 4. Right? So those are critical numbers. Right? So we got that. All right. Then we know that here, negative 9 is, we can look at this number line, is smaller than negative 5 or 2. So we know that we're going to have a concave downward. So we know that by second derivative test, this guy is going to give you, right? So this guy is going to give you a local, so concave downward, so it's going to be a maximum. Right? So that's this guy. And at 4, you can see that it's a concave upward. So we know that this is going to be a local minimum. Right? So relative maximum is going to be at x equals 9. and local minimum is going to be at the positive 4, right? So it's a negative 9 and positive 4, right? So let's type it in. Negative 9 and a positive 4. All right, so let's check the answer. All right, it came back and looks like we got part C correctly. All right, so we have find the x values of the inflection points of f. All right, so inflection point happens where the concavity changes. All right, so if you look at this, you can see that the concavity changes at negative 5/2, right? So that's the answer. So here, negative 5/2, right? 2. Because concavity changes from concave downward to concave upward, right? So, yeah. All right, so let's check the answer. All right, I came back and we got last part correctly as well. All right, that's it. I hope that this was clear.